All right, so here we're given a pair of limit expressions that describe the end behavior of each polynomial. All right, so what we have to do is we have to make sure we have these written in decreasing powers of x. Notice we have x squared, then x to the fifth. So this is really a minus 4x to the fifth plus 300x squared. And that's what p of x is equal to. So making sure your highest power is on the left, because remember when we were doing the theorem, it was a to the n, x to the n. That's what we want to pay attention to. Okay. And because of that, now we can say, okay, well, let's go ahead and do this. And so if we take the limit of that as x approaches positive infinity, that's going to be what? Well, if we plug in positive infinity here, we're going to get that goes to negative infinity. Because we're, again, if you put a plus here, that's to the fifth, that's still plus, but that becomes a minus. What about limit of p of x as x approaches negative infinity? Well, if we plug in negative infinity here, a negative, that's going to stay a negative. Negative times negative is positive. That is a positive infinity. Okay. So that's how the limits are going to be at those end behaviors. What about this one? Well, this one is written sixth and five. So this is a perfect order. So we could go and just go straight to the limit of p of x as x approaches infinity and the limit of p of x as x approaches negative infinity. Now, if we plug in positive infinity here, what do we get? Well, a plus to the positive is going to be a plus. This is a plus, so we're going to get a plus. And so it's just going to be a positive infinity. Now, if we put a negative infinity in here, a negative to the sixth power is positive, and positive times a positive is positive infinity. Okay. So really, the key here was the exponents as well as our leading term coefficient, positive or negative. Those really determined what happened in each of these problems. So when you had the negative out front, when you added the positive infinity, it made it a negative, but it made it a positive when you added the negative infinity in. Whereas this one, really, because that's positive, everything is going to become positive when you take it to the even power. And so both of those became positive. All right, what about this one? So if the total number of downloads, D in millions of a new app T months after its release is given by that function, find and interpret it, the limit as T goes to infinity of dt. All right, so what do we have here? So we have limit of d of t as t approaches infinity. All right, so here we're really going to be looking at the terms, the leading terms are kind of the key thing. And so what we want to do is we want to try to kind of isolate that. So if we do, that gives us 4t squared over a 5t squared. But we still have this piece here. And so what is that going to be? Well, that's going to be 1 over. Well, what we've done is we factored out a 5t squared out of this. So that's going to be a 1 plus, if we factor that out, that's going to be a 70 over, and that's going to be a 5t squared, right? And so now what we have to do is, okay, now I guess I didn't leave my room in here, so that's going to still be the limit as t goes to infinity of that whole thing. Now, basically, your t squares are going to cancel, and so now this just becomes, and if we take this as it approaches infinity, well, that's going to go 4/5. And then if you plug infinity in here, that's 70 over infinity. That's basically zero. That's 1 over 1. So that's going to be times 1 over 1. And so that gives us 4 over 5. Okay. Now, what does that mean? Because it says interpret. So that means over time, basically out t infinity, the total number of downloads, whoops, can't spell, will approach. And now it's 4/5. And what is our units? Millions. So it's going to approach 4/5 millions, 0.8 million downloads as t approaches infinity. So that's going to be our interpretation of that problem. All right, let's stop there and we'll come back with some more theorems.